Yeah, hi guys, yeah, welcome back to my channel. Today we want to look at balancing of chemical equation. First and foremost, we have to take a look at the history or where this balancing of chemical equation is coming from. So guys, this is it. In 1808, John Dalton states that atoms can neither be created nor destroyed, but can change from one form to another. So, what does this particular thing mean? Because Dalton take a look at it that atoms can neither be created nor destroyed, but can change from one form to another. For example, now, what Dalton means is that if I have A plus B and I have C plus D, this is my reactant side and A is my product side. What does that mean, class? So it means that if the atoms can neither be created or not destroyed, but can change from one form to another, it means that the atoms at the reactant side here must be equal to the atom at the product side. Again, the atom at the reactant side here must be equal, the same at the product side. Are you with me now, class? So, I want to look at some certain rules that guides this balancing of chemical equation. But before we go deeply there, balancing of chemical equation, I want us to quickly look at another view of this balancing of chemical equation. The first one is molecular chemical equation, which we want to take a look at. We also have ionic equation. This is under redox. We also have nuclear equation. So as you can see now, these are also the types of chemical equation or the balancing of chemical equation. But the main one we want to take a look at today is molecular chemical equation. And what are the rules that guides this chemical equation? I will state it. The first one states that the formula of the reactant and product must not be changed. That's the first one. While the second one states that the number which we appear at the front of the reactants, if you are given a compound, if you are to add a number here, also add a number here, also add a number here, that number you are trying to add at each of those elements is called trial and error method. So, and the second one, which Dalton lay emphasis on that atoms can neither be created nor destroyed, but can change from one form to another. That is, the third one states that if the atoms at the reactant side is the same, then the atoms at the product side must be the same. That is, they must be equal to each other. Are you with me now? So let's take a look at some examples. And these examples, I would love to relate it to those students out there preparing for JAM. This video is for you. Go on my page and pay max attention to the explanation of balancing of equation. So the first example goes thus. I have the first one. So I'll be dividing the board to make it look more. So the first one, I have x plus m and I have m for x3 as a jam bites. There is a way this question form come in different form, and when we go to that particular form, I would love to explain more on this, and that will show us how vast this balancing of chemical equation and the kind of dimension JAMB will set the equation. So looking at this now, here is the reactant side, don't forget, while here is our product. So if I should back the board, this hand here is my left hand, which will stand for this reactants. Are you with me now? This is my left hand. We stand for this reactants. And this is my right hand here. We stand for this what? Product. So with that, let's take it like this. I have here to be my left hand side, and I have here to be my right hand side. So how do we balance this? This is how it goes. So don't forget among the rules, what we call trial and error method. That is, if you try one number, it does not work, then you try another number until both sides are balanced. Now, at the reactant side, x is equal to 1, m is equal to 1. But going to the product side, our m is equal to 4, our x is equal to 3. Telling you that if I'm to balance both sides, the number at the product side, that is, the total number of atoms at the reactant side, must be equal to the total number of atoms at the product side too. So here, if I'm adding 3 here, why am I using 3? Because here my x is 3. So if I should make use of 2, I will have to clean it 2, because the rules also state that you must add one number. If it does not work, use another number. That is what we call the trial and error method. So now this times 4. So now it is very, very what? Simple. 1 times 3 is what? You have the 3 here, which will serve as the mole. And here we have the what? 4 here. So by looking at this now, my x here is 3. My m here is what? 4. So the reactant side and product side are balanced. So let's take a look at another example. Here I'll be using a compound. I have calcium plus nitrogen gas, then I have this. So class, by looking at this now, I have calcium here, I have my nitrogen gas here. So going to the other side, the number of atoms attached to calcium is 3, while the number, so we have nitrogen molecules. So with that now, don't forget the way we are solving it. We have the left hand side and we have the what? The right hand side. And don't forget, here is always the reactant side, while here is always the product side. So now class, this Ca, you write it out, we have 1, because the value here, invisible what? 1 here. So N, we have 2. Here, the same thing, calcium is 3, while N is 2. Now, the problem lies that our calcium here is 3, but our calcium here is what? 1. So what we're going to do that, if I should add 2 here, class, is not balanced, because you're having 3 calcium here, but here you're having what? 2 calcium. So we clean this, because we are looking at the trial and error method. So let's take it up by putting 3 here. Let's see if it's balanced. I have 3 calcium here, I have 3 calcium here. Good. So that 1 times 3, we have what? 3. I have 2 nitrogen here, I also have what? 2 nitrogen. So the reactant side, the number of atoms at the reactant side is equal to the number of atoms at the product side. So let's take a look at another one before we move to how JAMB puts their own questions. So I have SO2 plus O2, and I have SO3. The same thing here. So we have the left hand side, and here I have the right hand side. So now S is equal to 1. Let's go. 2 plus 2 here, oxygen will give us 4. S is equal to 1. O is equal to 3. Are you with me now? So class, if we have to look at this now, sulfur here at the left hand side, which is the reactant side, and sulfur at the right hand side, which is the product side, is balanced, but the oxygen is not balanced. So this is how it goes. So if I should add 2 sulfur here, or okay, you know it's not possible. When you said 4 minus 3 is what? 1. 1 atom is missing there. So this is how it goes. If I should add 2 here, Mind you, the 2 here and hard 2 here also, we also add 2 here. Let's take a look at this now. 2 times 2 is what? 4. 2 times 2 is what? 4. So our oxygen will be 8. While 2 times 3 here is what? 6. It is not balanced. So we have to clean this, also what? Clean this. So let's take it one after the other. If I should add 2 here now, let's see. 2 times 2 here is what? 4. Okay, plus 2, I have 6. My sulfur changed from 1 to what? 1 times 2, we have 2. And here, if I should add 2 here, because the sulfur initially was 1, and initially here also was 1. For me to have added 2 here, for me to have added 2 at the reactant side, then I must also do the same thing at the product side. So that was 1 times 2, we have what? 2. Then 2 times 3 is what class? We have 6. So you can see 2 is here. Let's have the same thing here also. So the number of atoms at the reactant side is equal to the number of atoms at the product side. Okay. So now let's take a look at the kind of question you will come across as a JAMB bites. But for you to come across that kind of question, you must have the knowledge of what you have on the board. So let's take a look at how JAMB sets their questions. So I have this. So this will be the 4th examples. So this one is how JAMB sets their question. Element X and element Y have when they combine, what is the formula? So class, when you look at this now, I said earlier that this balancing of equation is broad. How? Because the first thing you have to know is if we are given an equation like this, and so what the chemistry teacher asked them, when you are giving your students the electronic configuration, don't forget you have to put a comma there, because according to the above principle, we said you must fill in the lower energy before the what? Higher energy. So we are not assuming anything as a chemistry tutor. So looking at this now, I said I have 1s2, 2s2, 2p4. So this is how it goes. As a JAMB bites, want to solve it. Write that electronic configuration 1s2, 2s2, and 2p4. If let's calculate, let's add 2 plus 2 is 4 plus 4 8. The element with atomic number 8 is oxygen. Let's take a look at the second one. We have 1s2, 2s2, 2p6, 3s2, 3p1. So let's add everything together and see the element with the atomic number. 2 plus 2 is 4 plus 6 10 plus 2 12 plus 1 13. The element with atomic number 13 is aluminum. So JAMBites, this is my advice for you if you are preparing for this forthcoming examination. You need to be familiar with the atomic number of the first 20 elements from hydrogen down to calcium. So now, how does this, or how did it combine, and what is the formula from? So that's what we say we have aluminium plus oxygen. Then we have this and this. So when looking at what you have on the board there, the aluminium here is 2 at the product side, while this at the reactant side we have just 1 aluminium. So with the knowledge of what we have here, so just have to add 2 at the back of this aluminium because you have the idea already. Not initially when I was explaining, when I told you guys that we can use either by trial and error method. So here I'll be having what? 3 oxygen. So when looking at those two, we have 2 aluminium here, but good. We have 3 oxygen here. The same thing here, we have 2 aluminium here. We also have what? 3 oxygen. Telling you guys that the rules which I stated earlier, that the number of atoms at the reactant side must be equal to the number of atoms at the product side, which those rules being directed to John Dalton that stated that atoms can neither be created nor destroyed, but can change from one form to another. So let's look at this last question in form of this. Please and please, if you are having issues with electronic configuration, check my video catalog. You'll find where I explain extensively electronic configuration, which are itemized each of the rules that governs it, the likes of Ohm's rules, Haber principle. So we should not deviate. Let's go back to the class. So states and elements E. This is also a JAM question. Okay. So class, jam bites out there. This kind of question, majority of the students will be like, I cannot solve this. You can. Look at this now. This is split to it. They said an element E has the electronic configuration 1s2, 2s2, 2p6, 3s2, 3p3. So that's the same way we solve this now. So we can say we have 1s2, 2s2, 2p6, 3s2, 3p3. So let's add and look at the kind of elements with that number. 2 plus 2, 4, plus 6, 10, plus 2, 12, plus 3, that's 15, which is phosphorus. And they said the reaction of E, so our phosphorus is taken to be E with halogen X. So meaning that the halogen is being represented with what? X. So among all the halogens, starting from the group 7, we have fluorine, chlorine, bromine, iodine. These are the 4 common ones. So which one is going to react to it? You can pick anyone. I repeat, you can what? Pick anyone. Don't forget we have our atomic number of that element, phosphorus. So we can say E reacting with X. If I should have this, okay, sorry, I'm not using phosphorus, we are using E in the equation. So if I have this, At the moment when phosphorus reacts with something like this now, so and adding 3 to this, meaning I'll be also adding 3 to this. So now let's take a look at the picture now. Our E is P, then I'll be picking chlorine, then with this now we have what? PCl what? 3. So guys, I've explained the balancing of equation in line with the view of Dalton, and as well as the rules which govern the balancing of equation. And note one thing, at the end of today's class, I'll be dropping some exercise which at the end of the video you'll be able to practice on your own and see if you get it. And again, if you have any question pertaining to this you've come across in your past question, drop it in the comment box. Guys, don't forget to subscribe, like and share among your colleagues who are preparing for JAMB as well. So here is the exercise. Balance the following equation. So guys, play with this exercise and drop the answer